Okay, I'm going to talk about concurrent forces. So when forces applied on a body and their lines of action meet at a single point, that force is known as concurrent force. For example, let us consider a coordinate system. This is x, y and z. Here is a point on which there are some forces, and this force is like this. This is F1, F2, we can write like this. This is minus x-axis, and this is F3. What we see that all the forces, lines of action of all the forces are at same point. So this forces is known as concurrent forces. Okay. Now suppose direction of F1 is alpha 1. We measure this angle from x-axis, positive x-axis. This is alpha 2 and this is alpha 3. Then x component of F1 is F1 cos alpha, x component of F2 is F2 cos alpha 2, x component of x3, sorry, this is x3, is F3 cos alpha 3. So Fx is equal to F1 cos alpha 1 plus F2 cos alpha 2 plus F3 cos alpha 3. This is the net force along x-axis. Similarly, on y-axis, this is F1 sin alpha 1 plus F2 sin alpha 2 plus F3 cos alpha 3. For the magnitude of concurrent force, magnitude, this F is equal to under root Fx square plus Fy square, because of Fx and Fy are perpendicular to each other. So now what's about direction? Direction of resultant is given by tan alpha is equal to Fy upon Fx. Okay. Now if we calculate the resultant of these forces, there are 3, 4, 5 maybe, okay, and the resultant force is equal to 0, then we can say that at a single point on this body, at this point, net force is equal to 0. If the net force is equal to 0, then this concurrent forces is said to be in equilibrium. So we write here equilibrium of concurrent forces. What does it mean by equilibrium? When the net force of these concurrent forces, all of the vector sum of all the forces is equal to 0, then we say concurrent forces is in equilibrium. Now let us consider that at this point there are two forces, one is F1 and one is F2. And point of application is at single point, then we say this is the concurrent forces. What is the resultant? So for the resultant, we make parallelogram method. So this is the parallelogram method and this is the resultant. Now if we apply force opposite to R and equal in magnitude, just like this, F3, then what will be the net force on this? For this we calculate F1 plus F2, this is the vector sum, is equal to R, resultant, and we see that F3 is equal to R but opposite in direction. Then we can write R is equal to minus F3, because F3 is minus R. So F1 plus F2 is equal to minus F3. So F1 plus F2 plus F3 is equal to 0. it means net force is equal to zero. So this we call equilibrium of concurrent forces when the net force becomes 0. Now let us consider this is F1, this is F2. Basically we write from here F2. What will be the resultant of this force? Resultant is this. From triangle law of vector addition, this is R3, or simply we call R. Then we can write F1 plus F2 is equal to R. Now if we apply a force which is equal in magnitude of R and opposite to R, opposite direction, so let us take this is minus R, okay. Then what will happen? F1 plus F2 is equal to, or simply we call this is total sum is plus R is equal to 0. We cannot write like this, we write here F3 basically. So F1 plus F2 plus F3 is equal to 0. For this, net force is equal to 0 because by polygon method we see that there are some forces F1, F2, F3, F4, F5 makes a closed figure, then net force is equal to 0. Similarly, this is the closed figure is in same order, then the net force is equal to 0. Then we can say that the forces are F1, F2, F3, and their addition makes a closed figure, triangle, that force is equal to 0. That is the equilibrium of concurrent forces. Now we can write that triangle is the sides of triangle represent the equilibrium of concurrent forces if the sides are in same order. Same order means this is anti-clockwise, and this is anti-clockwise. Then we can write sides of triangle represent net force is equal to 0 if sides of triangle represent vector F1, vector F2, vector F3 in same order. Okay, so that's all about equilibrium of concurrent forces. So thank you.